Right, so in this video, we're going to be talking about groups of assembly language instructions. So in the previous videos and in the other videos, we talked about example assembly language instructions, example assembly language programs. But this is a different topic, and it is an important topic because it does show up in tests. So like a typical question might ask you something like, data movement instructions is one group of assembly language instructions. What are two other groups? So it is important for you to know all of the groups of instructions for assembly languages, and that is what we'll go over in this video. So one of the first groups is data movement. So data movement, and instructions in this assembly language instruction group basically control the flow of data either to from the accumulator and to and from different memory locations in your primary memory. This group contains instructions such as LDM, immediate load, LDD, direct load, LDX, etc. It also, so these are the loading instructions. There are also instructions like MOV. What it does is it takes an operand and it moves the contents of the accumulator to the register, and the register is what is specified in the operand. There's also something like the instruction Sto Store, and what this does, it also takes an operand and it stores the current contents of the accumulator in the memory address that is specified in the operand. And then there is also the end instruction, which is not your typical data movement instructions, and what it does is basically it transfers control, which was previously owned or contained within the program. It transfers the control of the resources, the processor, etc., back to the computer, so back to the operating system. So those are in general the data movement instructions that you need to know. The other group is input output, so IO, input output. Now these instructions are only two, as you might have guessed, input and output. They are IN for input, IN, and OUT for output. IN takes in a character and stores its ASCII value in the accumulator, and output displays the contents of the accumulator on the screen or whatever output device you have. The contents of the accumulator are in ASCII format, so it converts ASCII to your normal character. So that's input output. It's a pretty short category. There's not much in it. Next is arithmetic operations. So arithmetic operations contains commands for adding, subtracting, incrementing, decrementing. So examples of these commands are something like ADD. It signifies add, and it takes an address as an operand, and what it does is it takes the content of this memory location, for example, whatever it is, and it adds it to the contents of the accumulator. Similarly, subtract takes the contents of the memory location specified in the operands and subtracts them from the contents of the accumulator. Next up is increment and decrement, so INC and DEC, and this takes a register as an operand. So the operand value, I'll just draw two separate boxes here. The operand value can either be ACC or IX, ACC, IX. This is what it commonly is. If it's ACC, it means increment or decrement the accumulator. If it's IX, it means increment or decrement the index register. So those are arithmetic operations. Just give me a second while I clear my board right here. So I'll just erase everything so we can move on to the other groups. So after arithmetic, the next group is unconditional and conditional instructions. So although these are based on conditions, most of these commands are simply jumping from one place in the program, in the memory location, to another memory location. And we can either call these jumping instructions or conditional slash and conditional instructions. Conditional and unconditional. And examples of commands in this group is something like JMP, and this is an unconditional jump. So basically, whenever this command runs, it takes a memory address, so something like 103, and what it does is the next instruction that is executed. Let's say this was JMP 103 is instruction number 302. When this instruction actually executes, instruction number 303 will not execute, and instead the instruction at address 103, which might be something like LDD 97, that is what will execute. So the program will basically jump from 302 to 103 instead of going to 303 from 302. So that is the basic explanation of the JMP instructions. Now, conditional variants of the JMP instructions are JPE and JPN. So these instructions are always written, or they occur after a comparison of sorts. And we'll see this later, but CMP something operand is the compare instructions. So let's say, and what it does is it basically compares the contents of the accumulator with the contents of the memory address. So something like, if I say CMP 103 is going to compare the contents of the accumulator with the contents of memory address 103. And depending on the outcome of that comparison, so that comparison can either be true or false. So if they're equal, it's true. If they're not equal, it's false. Depending on that comparison, JPE or JPN runs. Both of them cannot run at the same time. It's either or. So it's like a Boolean value, true or false. So JPE runs if the compare instruction gave a true result. So if they were equal, then JPE would run. Both of these commands take operands as memory addresses, so something like 103 or 105. If the comparison is true, JPE will execute and it will jump to 103. If the comparison is false, JPN executes and it jumps to 105. Right, so those are unconditional, conditional, or jumping instructions. And finally, we have our compare instructions that we just talked about. So comparison. This is most commonly the CMP instruction is used. So CMP 103, we just talked about this. It compares the contents of the accumulator with the contents of the address that is passed in as the operand. Similarly, we don't always have to pass in a memory address. We can change what type of operand we're passing by adding a prefix. So CMP will hash something like 97 would compare the contents of the accumulator with the decimal number 97 and not the memory location 97, the contents of the memory location 97. So this is all because of the hash that we added, the prefix. Other than that, we can also use CMI, which is compare using indirect addressing. And this comes under addressing modes, which you probably learned in another video. Right, and those are all of the groups of instructions of assembly language that are in our syllabus at the moment. Hope you learned something. Catch you in another video. Thank you for watching.